Now we're ready for Chapter 6, Communicating with Other Hams. So what the chapter covered in your book was got into where and how contacts are made with other hams, using repeaters, which we'll get into a little bit, how you participate in nets. And nets is just like a group of hams that get together for various reasons and can do anything from emergency communication to just a social chat function. We'll touch on some public surface communications and some of the organizations involved with that, in case you might be interested in getting involved. Then which amateur emergency organizations there are that you can participate in, and satellite operating. So we'll start getting on with this. But before we get into Chapter 6, I want to go back and do a little follow-up. We're at about the midpoint of the study group series. And if you recall, in our first session in Chapter 1, we talked about getting your FRN number. That's the number that you'll need to take the FCC test. And if you haven't done it, I would strongly suggest you go ahead and do it now as quickly as you can so you don't forget it. And the process is pretty straightforward. You just go to, let me turn on my lightsaber here. There it is. Process is pretty simple. You just go to this web page, and then this is what that web page will look like. And you just click on register underneath a username, and you go on from there, and it'll walk you through it. And I believe the FRN number is sent to you pretty quickly, and then you'll have it for your test. And I'd recommend that you keep the number in a safe place, because anytime you deal with the FCC, it'll require using the FRN number. So we'll go on to the next step. And just a check here. Like I said, we're about halfway through the study series. If you haven't started taking some of the practice tests, you might want to consider doing that now. Since we're halfway through, you probably aren't going to pass the test, but I think a good way to go about your practice test from here would be that when you finish a chapter and answer the questions, go online and do, say, 3 practice tests, and then write the scores down for that chapter in the title page of your book, or the index page. And if you do that for each chapter, what you should see is that as you progress, your scores should get better and better and better, which would be a good indicator to you that you are getting the information you need, even though you may not be passing at this point. But each chapter, you're getting more and more knowledge and doing better and better. And that would probably give you some good confidence after you complete the study groups and are ready for the test. So I would highly recommend that you come up with some sort of practice test procedure at this point. Okay, to kind of get us reoriented with the band plan. I know we covered this in the last chapter, but that was in terms of equipment selection and operation. So we'll just take another quick look at the band plan. And as you recall, most of your frequency privileges are going to be in this range here, these particular bands. And it's 10 meters, for example, you have limited privileges in both CW and phone part of the band. All these other bands are require a general or extra or advanced license in order to transmit on them. You can monitor any of the bands. In fact, you can monitor any frequency you want on the spectrum. It just the license is required to transmit. So it'll be this part of what you'll be primarily working with. And then specifically in the technician privileges, probably most of your work's going to be done on 70 centimeters and 2 meters. And probably with an HT or some sort of a VHF, UHF mobile radio like we talked about in the last chapter. So now we're going to take a look at two ways that you can communicate with other hams. One way is shown here in the top picture. Oops, I need to get my lightsaber out here. There we go. Okay, so the top one is describing simplex. And what that is, it's a mode of operation where both radios of the two hams that are wanting to communicate are set to the same frequency, in this case 146.520 megahertz, and you both send and receive the signal on that frequency. Another approach is to add another piece of equipment to the system, and that's referred to as a repeater, and or it can also be referred to, you might hear it called duplex operating. And in duplex, what happens there is that the two parties, they both transmit on the same frequency, and then what the repeater does is it instantaneously takes what's transmitted and retransmits it on a different frequency. So if the fellow here in the truck is transmitting, he's transmitting on 147.720, and the repeater picks that up and then it retransmits it at a different frequency, 147.120. So in a repeater system, there are two frequencies that you're working with. One is the received frequency, which would be the red frequency here in this example, and the other one is the transmitted frequency that your radio will actually transmit. And most of the radios are set up so that when you say program a repeater into your radio, you put in the receive frequency that you're going to listen on, and then the radio or the program that you're using to program your radio will know from this frequency, the receive frequency, what the transmit frequency will be, because there are recognized offsets, and we'll get into that in a little table a little later. Phone call. I'm back. That was the boss on the phone there, so took care of what she needed, and back now looking at simplex in a little more detail. This is the operating mode where both the transmissions and the receive signals are on the same frequency. Now, part of the band plan, and this is a little finer detail getting into it, is there's agreed upon frequencies in the simplex band that and the way everything is staggered, so we don't get into getting in each other's way. So for 2 meters, for example, the FM simplex range is 146.40 to 146.58. And it's a generally agreed upon practice that we reserve 146.52 as the calling frequency, and this is on 2 meters. Okay, so this is the calling frequency, and the way this works is if you want to talk to someone on simplex, maybe when you're driving, or if you're just at home and on your handheld, you get on 146.520 and you call CQ or announce that you're listening. And if somebody comes back to you, since this is a calling frequency, what you agree to do with the other guy is to move to another frequency so that we leave the calling frequency open for other people to make contacts with other hams. So you'll call, make a contact, and then you'll agree to maybe move down to one of these other frequencies. Now, one thing on the 2 meters is that the way the frequency channels are set up is that there's 30 kilohertz between a frequency. And you can see that each one of these is 30 kilohertz higher than the previous one until you get down to the last one. And the reason for 30 kilohertz is that a typical FM signal, the bandwidth for that is 25 kilohertz. So what we want to do is to place these frequencies with enough offset. By going to 30 kilohertz, you won't get interference between these. So if you're on a 2 meter simplex, these would be the frequencies you designate to go to. And then if you go to 70 centimeters, or the UHF band, then the FM simplex calling frequency is 446.000. And then the spacing on that is 500 kilohertz. And one thing you'll find in this area is that we check on this on our weekly net, is that the UHF simplex band does not operate as well. We have more trouble making contacts than we do on VHF. So most of your simplex work will probably be on VHF. But as part of our weekly net practice, we also check out the simplex frequencies on 70 centimeters. Now, when you look at a repeater, there's a couple of things you need to be aware of. One, the repeater, as we talked about, operates with two different frequencies. A frequency that it transmits the repeated signal, and a frequency that it receives the signal to be repeated. And the difference between those frequencies can technically be about any frequency difference, but the generally accepted practice is an offset when you're on 2 meters plus or minus 600 kilohertz. So let's say our receive frequency is 145 megahertz. And then, so that means, depending on where we are in the band, the transmit frequency will either be 600 kilohertz higher or 600 kilohertz lower than that one. So this standard offset is pretty consistent with most repeaters. There are some repeaters that are not standard like that, and the offset may vary. So that's something you have to keep an eye out when you start programming repeaters. So on the 70 centimeter band, UHF, which runs 440 to 450 megahertz, the offset is plus or minus 5 megahertz. So it's just by designating the receive frequency, the radio and the software can figure out if it's a plus or a minus 5 megahertz if it's a standard offset. Now this is a table out of your book, and it's kind of busy, so I thought I would explain it a little bit if I could. On 2 meters VHF band plan, the repeaters are designated here. Here's an FM repeater input. Here's an FM repeater output. So if you're in this frequency range, then the let's see, where am I? Okay, here's the other repeater output and repeater input. So there's two sections in the band here. One has a plus offset. So if you're in this range, um, of frequencies, then the offset's going to be plus 600. If it's down here in this range, then the offset's going to be minus 600. And that's why the radio or the programming program will know, um, depending on the input frequency, whether it's a plus or minus offset. There again, though, if you have a non-standard offset repeater that you're programming, then you'll have to overwrite the standard offset, which isn't a big deal to do in the programming program or even in the radio, but it is something that you'll have to do if you have a non-standard offset. And then other bands also have repeaters. We just looked at the 2-meter band where there are plus or minus 600 kilohertz standard offsets, the 70 centimeter plus or minus 5 megahertz. And then if you happen to encounter a repeater on 10 meters, the offset would be minus 100 kilohertz. 6 meters, as noted here, it varies by region. So you'd have to know the information of the repeater. And then these other 1.25 meters, 902 megahertz, and 1296 megahertz would have their standard offsets. So depending on what band you're on, will determine what the standard offset is. A repeater can be set up to where it will only retransmit intended signals. So if it isn't set up this way, what will happen is any signal that the repeater receives on the programmed frequency will be automatically repeated and transmitted. So one way to make sure that only intended signals are retransmitted is the use of what's called a tone. It's also referred to as a continuous tone coded squelch system, CTCSS, or it can be called PL, which is a trade name for Motorola, and there's some other designations. But essentially what it does is that the repeater is programmed so that it will only repeat a signal that it picks up that has a certain frequency tone in it. This tone is a low subaudible tone that you really can't hear, but the repeater can detect it. And when you transmit with the correct tone frequency, that tone is added to your signal. The repeater will sense it and then go ahead and repeat the transmission. So this is a list of what the standard tone frequencies are, and these are all in hertz. The tone frequency is somewhat standardized within an area. For example, in our area, a lot of the repeaters are set up with a standard tone of 173.8 hertz. And for example, our group's repeater is programmed with the 173.8 tone, so that it'll only retransmit those signals received that also carry that 173.8 tone. And you can either set that up in your radio if you're programming the frequencies in the radio by hand, or this is an example of a program that can be used to program a VHF UHF radio. And the way you would designate the tone would be to select the tone, this box, and then select what tone frequency it might be. There are a lot of different ways that you can set up a repeater depending on what you want to do with it. There's conventional repeaters, um, satellite repeaters. There are actually satellites orbiting the Earth that can act as a repeater, and that's kind of a fun thing to do, to where you have to identify when the satellite's going to be overhead, and then you can try to contact hams elsewhere around the area using the satellite repeater. The one I wanted to particularly point out to is the technique called a crossband repeater. And this can be done with your own VHF, UHF radio if it has the capability, and can give you some pretty good flexibility and capabilities if you're out and need to have like a temporary repeater system. So what you end up doing, say if you have a mobile radio in your vehicle that is capable of crossband repeating, the crossband repeater function can be set up in your radio so that what you can set up a uh, re receive uh, channel or frequency on, in this case, UHF, the 70 centimeter band, so that people on, say, down here at the bottom of a hill with handhelds, the HTs, can transmit to your vehicle, and then the radio will repeat what's transmitted on 70 centimeters onto the 2-meter band, which can be used to go back to net control or even another repeater. And then when the vehicle receives a signal, either from net control or another repeater, it'll retransmit that or repeat it on the 70 centimeter band. The other thing, I use this at home, and I've got a 50 watt base radio in our shack with a good outside antenna, and I can just carry my handheld around the house or around the property, and effectively have the uh, 5 watt handheld radio behave as if it was a 50 watt um, radio with a good external antenna. So you could be out in your yard, have your crossband repeater set up in your house, and have it connect to uh, the local repeater, and then you have a very good higher powered communication system to the repeater just using your handhelds. And this is kind of a diagram in Treasure Lake of how we could set this up if we wanted to. We've identified, for example, in this case, we've got 3 hams, the blue triangles, that have crossband capability, VHF, UHF radios. The idea being that we could set each of these up, and if you were in a particular area and couldn't reach the repeater with your handheld, you could reach a repeater through the crossband repeater closest to you. So it's just a pretty slick way, in my opinion, of getting yourself extra range with the existing equipment that you have. And then there's a variety of different linked repeater systems. Now, what that means is that a repeater can be configured if you have internet access at the repeater site, so that the handheld or your base station can transmit to the repeater antenna, goes through the repeater, then a PC will encode the information um, and transmit that on the internet to another PC that's also hooked to a repeater. So this is the way some of the modes we looked at, like D-Star and Fusion, DMR, can be used to get worldwide communication just using a handheld and a nearby repeater. Just a note, and this is entirely my opinion, my definition of modes to use for emergency communications, and this is just my own definition, is that if you have to use grid power, cell phone technology, or the internet, I don't consider that acceptable for emergency communications, because any one or all of those could be down in an emergency. So you would need to use something else that didn't require those infrastructure components to maintain communications. But it is a pretty neat way to do what I call recreational ham radio, where you can talk to people all over the world just with a little handheld and a local repeater. And if you don't have a local repeater that has this setup, you can set it up yourself with a device like this, which plugs into a USB port. And what this essentially is this particular one is a UHF transceiver. It can send and receive to your handheld, and then it'll convert the signals here through the PC and then go over the internet to other stations that are set up in similar fashion. So you don't necessarily need the repeater if you have a system like this. And some of the more well-known linked repeater systems are listed. This was the IRLP, Internet Radio Linking Project, was one of the earlier ones. You may run across Echolink, Wires2, D-Star, All-Star, WiresX, and there are a bunch of others around that can be used to do pretty much the same thing using the linked repeater concept through the internet. Now we're going to talk a little bit about nets. And what you're seeing on the screen here is the script that we use to conduct our weekly nets. And I'm not going to read through the whole thing. You can read it, pause the video and take a look at it if you want. But essentially, it's the process we use to identify who's on the air with us and pass information back and forth. So it starts with an opening announcement, states the purpose of the net, gives the time, the access tone, explains how check-ins will be handled, makes announcements for the net, gives the people that are participating in the net the chance to make announcements, and then start going through the check-in process. And for example, we always start with stations in Treasure Lake, and net control will call the call signs, and then the people that are on the air will respond, so we can fairly quickly get a pretty good idea of a list of who we're able to communicate with. This is also, we also have an emergency net script that's similar, but it has a few more control functions in it that you would need to do during an emergency. So this is how a lot of nets are initiated, and just to give you an idea of how we do it here in Treasure Lake. Another key practice for improving communications on the air is the use of the International Telecommunication Union phonetic alphabet. A lot of the information is always sent with the station's call sign, so rather than using the letters, for example, my call sign is K3SKS, particularly if there's a noisy environment. Some of those letters can be misunderstood. So in order to improve the chance that the receiving station will understand your call sign or any other word that you need to make sure is copied correctly, is to use this phonetic alphabet. And for example, instead of saying K3 SKS, I would say Kilo 3 Sierra Kilo Sierra. And then the receiving station can copy that much more reliably. And this is something, you don't have to study this for the test, but as you spend more time on the air, you'll become more comfortable with using the correct word for each of the alphabet characters. Then the other thing that has been developed is the use of what's called Q signals. And this originated in the telegraph, early days of the telegraph, early days of radio communications with Morse code. And the idea there was that there were standard Q signals that you could send that people would know what you're talking about. For example, here's a QRT means you're going to stop sending, or asking if you should stop sending. Let's see. QSL is another one where you're either asking for someone to acknowledge you if it's asked as a question, or if it's a response, it's affirming the answers to the question. And a lot of times people, rather than responding, if somebody asks you, is that correct, or they send you a QSL, a lot of times people, rather than saying QSL in response, will say Roger, or Roger that, something along those lines. But these, there's just a lot of Q signals that are available. And what you'll find is, depending on what you're doing, what type of radio operations you're doing, you'll become familiar over time with the Q signals. And for example, on our Monday Night Net, we do what's called a QSY exercise. And QSY means change transmission to another frequency. So we start off our net on our repeater, which is a UHF repeater, and then after we get all the check-ins, Net Control will announce that we're going to QSY to the next frequency. And the Net Control will tell you what that frequency is. Then everybody changes their frequency on the radios to that frequency. We go through the check-in. Then we QSY to another frequency on UHF simplex. Everybody checks in, and then we QSY again to the W3CPA repeater in the Clearfield area, and everybody changes to that frequency. So everybody that checks into our net's fairly familiar with the QSY Q code. QTH is your location, where you're operating from. Generally, if you're doing it from home, it's your home. And let's see if I can see some other ones that there's QRM and QRN, and both of them deal with noise. For example, you could tell someone you're having trouble copying them because of QRM, Queen Radio. I have a brain cramp. I forget what the phonetic code for M is. But the distinction between QRM and QRN is that QRM is man-made noise. Typically, that'll be either intentional or unintentional. Maybe a station is too close on frequency to your frequency. And then QRN is natural noise, lightning, that type of thing can be described that way. So this is just, you'll pick these up as you go along. Well, I guess I could have looked over here on this side. M is Mike. So it would be Quebec Romeo Mike is QRM. Quebec Romeo November is QRN. And then this is a repeat of the phonetic alphabet over here. And you can go to this link at the bottom to find these sources. They're pretty available all over the internet in ham radio world. Another tool, or yeah, I guess tool would be a good name for it, of identifying your location, is the use of what's called the Maidenhead Grid Square Locator Map. And there the whole world is mapped out with these grid squares. And there are programs, this are not programs, but web pages, this being one of them, that you can go to determine what your location's grid square identifier is. Now, I did two of them here. This one, I put in my call sign, and based on the FCC database, it spotted me here, which would make anything inside of this box, the grid coordinate would be FN01PD. And then if you put in the address, it spotted me correctly here on Lake Bimini, and that was also FN01PD. So there are ways of determining your grid square, and a lot of people that are giving their location give it by the grid square. And the grid squares set up so that the more characters there are, the finer detail it is. So you could give a grid square of FN01, and it would be a large area, which would include the box that you see there. And then if you further resolve the grid square by adding the PD, it limits it down to this area here, where your QTH is. This is a radiogram. It's a technique, or it's a form used actually all over the world for passing messages from one station to another, and particularly going to a third party that's not a ham. So if you're in a situation where you need to get a message to someone, say in Washington State, there's a way you can set up a radiogram and read this to the receiving station, and they'll copy it, and then they could forward it to the party that you want to get in touch with to pass on the information. There are programs that can do this for you. Fill them out on the computer, or you can do them by hand. And there's a procedure you go through to fill in each of the blocks. So that's probably a skill that would be good for you to develop at some point. Now we're going to take a look at emergency communications and public service using ham radio. And in our area, anyway, there are two main organizations of hams that participate. They're organized to participate in an emergency. And the first one is called ARES, or Amateur Radio Emergency Service. It's affiliated with the ARRL, which is Amateur Radio Relay League, and that's the largest organization of hams in the country. And their function is to support local and regional organizations such as the Red Cross, Salvation Army, National Weather Service in transmitting information during an emergency. Then there's another group, abbreviated RACES, for Radio Amateur Civil Emergency Service, and they're affiliated with, in our area, the Pennsylvania Emergency Management Agency. And their function is to provide emergency communication services in an emergency with the state emergency agencies. So it's good to know where both of these organizations operate on the band, so that in the time of an emergency, you can monitor, and if need be, uh, send traffic to them if help is needed, and those types of things. And then as far as knowing where these agencies are, this is a table we worked up where the ARES frequencies are listed here, races are here. A third organization that works in emergency communications is Saturn, which is the Salvation Army Emergency Network. Um, and you can see here there are predetermined bands and frequencies that are used, uh, modes that are used to conduct nets. So, for example, the Western Pennsylvania ARES net operates at 3.983 megahertz, which is on the 80-meter band, and uses analog single sideband, and that's the primary net for communication in an emergency. They also conduct weekly and daily nets um, for keeping hams in touch. And then, for example, if there's a problem with using this frequency due to conditions, they have an alternate frequency on 40 meters they can go to. And then there are a local repeater that's designated for emergencies, and then the simplex frequencies. Similar setup for the RACES group, Saturn, and then these are the frequencies that we've selected in Treasure Lake for emergency traffic. And for example, these frequencies here are 2-meter simplex frequencies. And rather than trying to remember all the frequencies, we've designated we call it EPT VHF1, which is the national calling frequency at 146.520. And then we've selected 3 other frequencies on the VHF simplex and designated those frequencies that we would go to. And for example, on our Monday night nets, when we do a QSY, we generally go to EPT VHF2, and everybody has the radios programmed for that, and they don't have to remember this number. So net control announce let's QSY to EPT2, and everybody knows what frequency to go to. And then a similar setup here for the UHF simplex frequencies. Here's the national calling frequency. And you could use these if you're just doing normal simplex work. You would know that V1 and U1 are the calling frequencies for VHF and UHF. And you could go there. If you make a contact, then you could tell the other person we need to QSY to maybe UHF2 here at 445.950. And then we've also designated a few frequencies in the 10-meter band that we would use for single sideband. And then here are the links to these various agencies that are on this page. So it's a good reference to have printed out somewhere if you ever need it. There's another type of communication that you can do, which is a digital communication, not digital in the sense of D-Star or DMR. It's not a voice communication, but it's keyboard to keyboard. And there's a system that you can set up on your computer with software, and all the software is free. It's called the Narrowband Emergency Messaging System. And what this does is it enables ham operators to communicate keyboard to keyboard so that you can type and send messages. And this is a blow up of what you would send and receive using this system. For example, you wouldn't use a microphone, but you would type this, and the way this is read, DE means this is. He's identifying himself. He identifies himself with his call sign and repeats it twice, gives his name, the county. I'm not sure what 930 is or what that is. And that will be transmitted, and other people can receive it. And here's someone responding to him, identifying himself. There's a Q code. Here's a call sign. So this is checking in for a net. So this fella, Jay, this is his call sign, WA2UAR. He's in Philadelphia, Pennsylvania. Dell's in Levittown, Pennsylvania. And David's in Reading, Pennsylvania. So this is what a net on the NBeam system would look like. There's no spoken information. It's all keyboard to keyboard. This is particularly useful for emergency communications because there are different modes that you can select in order to communicate. And if you remember what a mode is, we talked about it, I think, in an earlier chapter. It's the way that you encode and decode data. And there are modes, there are trade-offs on modes. There's good things and bad things about them. For example, some of the modes that are contained in this system are very fast. You can type quickly and send messages quickly, but the cost of that is the accuracy of the message. Noise may interfere with it. And then there are other modes if you have particularly noisy conditions or you have critical information that has to be transmitted error-free. You can switch to another mode that's designed for that capability. It generally will be slower and or require wider bandwidth, but you can switch to a mode where you have to absolutely make sure that the information is correct. And there's just a lot of capability in this system. Once you get it set up, it's pretty handy. The other thing I like about this in an emergency situation, particularly an emergency that may extend overnight or for several days, is that you can leave this running, receiving, and it'll copy everything that's transmitted while you're away from your station. So let's say you go to bed. If this is running during the night in an emergency, you get up in the morning and come back and read all the emergency transmissions that were made while you were asleep. The trouble with a voice communication is you have to sit there and monitor it or record it and then go back and replay it, which is pretty cumbersome or can be cumbersome. So this is a particular area that right now, this was, it's March of 2022, and our ham group's working on getting this set up for our local operation, and we'll probably have it up and running here in the next month or so. So it's something that's a pretty good tool to have. And there's a lot of recreational things that you can do with this too, in terms of contests and discussion nets, those types of things, and just calling CQ and talking to people. So it's just another thing you can do with ham radio that you may not have known you could do. Another system that can be used is called WinLink with ham radio, and that is essentially an email program. And the way it's set up, this looks like a typical email package where you have all your different messages. Here's this message. This message right here is shown here. And you can send emails with or without the internet. For example, you can transmit from your station to another station that's identified in the software that is hooked up to the internet. So if you have someone that's not a ham and you want to send them an email message, you can use this email system and it'll interface with the internet and get the email message to the person you're wanting to get it to just from their email address. This can also be set up, say if the internet's not working at all, that you can send emails from one station to another, and you can attach files and those kind of things. About everything you can do with a normal email, you can do with this without ever using the internet. So that's extremely valuable in an emergency situation where the internet may be down or partly down in one area. Because let's say Pennsylvania's internet's down, you can contact a station in New York that's hooked up to the internet, which is still functioning, and then you can still get your messages in and out from an area that doesn't have internet. And there's satellite operating. Essentially, in this case, um, there's a variety of satellites orbiting the Earth that have ham radio repeaters on them, and you're essentially using, instead of the repeater being on top of the hill, it's up in space, and you can contact directly through the radio waves another station on different places of the Earth. So that's kind of a fun thing to do. And there's software to help you do the satellite operating. The one I'm most familiar with is Ham Radio Deluxe, and it essentially, once you get it set up and say tie it into, this is a pretty exotic antenna system here. The challenge with the satellite radio is that the satellite is moving very quickly overhead, and you have to have the antenna tracking that satellite to keep the antennas aligned with the antennas on the satellite. So what the Ham Radio Deluxe does for you is it controls the servo mechanisms in your antenna system. So once you designate the satellite, it'll know when it's coming up off the horizon, and it'll track the satellite through the sky while you're talking to whoever you're talking to on the other end of the conversation. There's also a situation with satellites in that because they're moving so fast, there's a frequency shift called the Doppler effect, and you're probably most familiar with the Doppler effect of a train passing you on the railroad tracks, how it sounds higher frequencies that's coming towards you, and then as it passes and goes away, the frequency, it starts sounding lower frequency, and that's what that Doppler shift is. It's a frequency difference due to the relative speed between the train and yourself. Excuse me. Well, you have that same effect with a satellite, so that the frequency on your radio has to change as the satellite approaches you, and it continues to change as it passes overhead, and then as it moves away, you've got to keep changing the frequency to stay on frequency. And this software can take care of that for you once you get everything set up. So that's a lot of fun. It sounds like something you'd like to do. All you need is your license, and it's all VHF, UHF, so you can do it as a technician.